All right, hello grade 8s. Today we are going to do the square root of non-perfect squares. So what does that mean? Well, we learned about perfect squares last time. So a perfect square would be a number like 4, where when we take the square root of 4, we get a whole number 2. Or another perfect square would be 9, where we would get 3. Or 16, where if we took the square root, we would get 4. Okay, so a non-perfect square would be like, what happens if we wanted to get the square root of 5? What would this equal? So this is what we're going to cover today and go over, and I will show you how we can estimate it and use our calculator to solve. So let's get into it here. So the first step in this process is making a perfect square number line. Okay, so let's draw ourselves a number line. Here we go. And we will put our arrows here and here and here and here. Okay, so we are going to make some dashes along the line. Very nice as we go. And number lines are nice because they show us a visual representation of numbers. So let's start off by labeling this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now up top, we are going to put a square, the square, okay, the square number that when we take the square root of it, we get the number on the bottom. So let me show you what I mean. So on the top, we're going to put the square root of 1 because 1 times 1 equals 1. And so the square root of 1 is 1. So for 2, we are going to put 4. The reason is because that 4 is equal to 2. The square root of 4 is 2. The square root of 4 is equal to 2. Up top here, we're going to put 9. Up top here, we're going to put 16. 25 here. 36 here. 49 here. And 8 times 8 is 64. And 81. Okay, so we're going to put all of our square roots up top above this line. Now, what this means is if we were to try to find the square root of 5, which was the one we mentioned before, what we can do is we can look at our number line and say, okay, where along here does the square root of 5 fall? Well, it would fall between 2 and 3, right? Because this is the square root of 4, this is the square root of 9. Square root of 5 goes in between here. So it would fall in between, and it would be closer to 4. It would probably fall around here. So now we can estimate that our decimal, so the answer to this as an estimate, would be something maybe like 2.1. Do you see why we estimated that? Because it's closer to 2 on the number line. So 2.1 would be here as opposed to over here, which would probably be about 2.9. But square root 5 is right here, so we would have 2.1. And now what we can do is we can take our calculator, let's see if we can find that, and we will test this out. So we can do 5, and we'll hit our square root button over here, square root 5, and we get, okay, 2.2. So we were a little bit off, but that's all right. We were close. So that's the deal with this unit. We are estimating what square roots are when they're not perfect squares. Okay, so let's try a couple more examples. So there are 2 ways in order to do this. We can use perfect squares to estimate, which is just what we did back here. We used our perfect square number line, or we can use a calculator to double check. Okay, so these are our 2 ways. So let's jump over to this portion first. So let's try to do 72. Okay, so let's make ourselves a number line. Here's our number line. Okay, and now 72, we need to try to think what 2 perfect squares would be on either side of 72. Well, on this side, I can think of 9 times 9, which is 81. Okay, and then on this side, let's do 8 times 8, which is 64. Okay, so we know that the square root of 72 is going to fall somewhere in between here. And if we think about 72, it's about, you know what, 6, 7, 8 higher than 64, and it's about 9 lower than 81. So actually it's going to kind of fall somewhere in the middle, a little bit closer to 8. So it would fall somewhere around there on our number line. So we could estimate that this might be maybe 8 point, I don't know, what do we say, 8.4? Could be the square root of 72. Okay, and then we can check our answer on our calculator. Let's go over here. And we'll type 72, and we'll type the square root, and we get 8.48. So pretty much 8.5. So this was a pretty good estimate that we had. Now, when I write out estimates, I like to do squiggly equal signs. approximately 8.4, and then we can say it is actually 8.5. Okay, so what we did is we just estimated where 72 would be and we checked with the calculator. Okay, let's do the other two here. 103. So let's just clear up our dealio here. Keep our line. Okay, so let's take 103. So I can think of, oh, that's not what I wanted to do. I can think of 10 times 10, which is 100. And then on this side, we could do 11, right? 11 times 11 would be 121. So 103 would fall quite close to 100 because it's only a little bit above that, and it's pretty far away from 121. So we could estimate 103 at, let's say, 103, our estimate will be maybe, I don't know, 10.1. How about that? 10.1. Okay, and let's estimate 55 now at the same time. So 55, we will sketch out a new number line up here. 55, we could do 7, right? Because that would be 49. So basically, I'm trying to find on either side of 55 what the perfect square would be. On this side, we would have 64. Okay, so 55 might be a little bit closer to 49 by a little bit. So maybe around here. So our estimate would be maybe 7 point, I don't know, 4. How about that? 7.4. So we will say the square root of 55 estimated at 7.4. Okay, now let's check these out. So 103 and 55 with our calculator. So we're going to do 103, and then we're going to hit the square root button, and we get 10.1. Very nice. 55, hit the square root button, and we got 7.4. So you can see we are pretty accurately estimating the square roots of non-perfect squares. So that's kind of what we are doing. 55, and it equaled 7.4. Okay, so that's how we do that. So let's take a look at the problems at hand here. So here we go. What is the area of the middle mat? Well, we can see that this area is 49 meters squared. So we have a few squares here. So let's just sketch it out. Actually, yeah, we'll sketch it. Sure, why not? So we got that. Oops, that didn't really turn into a square. Just imagine those are squares. Okay, there we go. Let me try to just make it nicer again. Let's see here. The nice thing is we got this on video, so we got to make it good. Oh, that didn't. You know what? These are close enough for what we're doing today. So up here we have the square at 49 meters squared. Okay, and down here we have 36 meters squared. So in the middle, we're looking for something that's in between 36 and 49, and it's pretty much in the middle, right? Like it looks like it's about half the size of both of these, or sorry, not half the size. It's right in between. It's right in the middle of both of these mats. So if we were to sketch out our number line again, we would have the square root, which is of 36. These are perfect squares, which is nice, is 6. And this one is 49, which is 7. Okay, so now we could see that probably in the middle here, we could see 49, 36. So maybe somewhere in the middle would be around, what are we thinking? Maybe 41, 42. So 42 would be a fairly reasonable estimate for the size of this mat because it's pretty much in the middle. And the side length of the mat would be 6.5 meters. Okay, so you can kind of see we're using the number line again. So let's check out another problem. Here we go. So Felicity wants to know if a wading pool will fit in a small space in her yard. She must estimate the side length of the square wading pool. Okay, so we know it's a square, and she's trying to estimate the side length. So if we have an area of 7 meters squared, and we need to find the side length, what we need to do is we need to find the square root of 7 in order to get the side length. So we need to figure out what this is going to be on our number line. So let's check this out. We'll make a number line again. If we did 2 down here, this would be the square root of 4. And if we did 3, this would be the square root of 9. So the square root of 7 is going to fall somewhere in between here, a little bit closer to 9. Right? Square root of 7. So we could say this might be around 2.9. I don't know, 6. How about that? 2.6 would be our estimate. So this would be a reasonable estimate for the side length of the pool. 2.6, it said to the nearest 1 decimal place. So this would be our answer for that one. And then we need to, B says use a calculator to double check our answer. So let's grab our calculator. Let's hit 7 and let's hit the square root button. And we get 2.64, so 2.6. So our answer is 2.6. Yay! So we're dealing with this number line and we're trying to estimate. One more type of question you are going to be asked in this unit, which is what is a whole number that has a square between 6 and 7? Okay? So what we're going to do is we are going to, once again, start with the number line. That's the theme of this. So we're looking for a square between 6 and 7. So we know 6 would be here, 7 would be here. 6 squared is 36. 7 squared is 49, right? So we kind of have our number line again. So what we're looking for is a whole number that has a square between 6 and 7. So any number, any whole number that would lie in this area in between in the number line would be an acceptable answer. So we can think what's in between 36 and 49, that's a whole number. Well, we have a lot of options. We have 37, we have 38, we have 39, we have 40, and so on. All those numbers that are whole would all be acceptable answers for this question. So why don't we do 44? Because that's in between. So this would be an acceptable answer because the square of 44 would fall somewhere between 6 and 7. It would be a decimal, 6 decimal something. And so this bottom question here says, how many whole numbers can you find that have a square root between 6 and 7? Show your work. So we know that the 7 squared is 49, 6 squared is 36. So we could take 49 and subtract 36 to figure out the amount of numbers that we could have between 6 and 7. So 49, 9 minus 6 is 3, 4 minus 3 is 1, 13. So 13 numbers, 13 whole numbers have a square root. Root between 6 and 7. Okay, so that's how that is working. So the last example, let's do it together. So Kai uses an entire can of paint on a square backdrop. So we know it's a square. We're always picking out our key information. Square backdrop for the school play. The label on the can states that one can covers 27 meters squared of wall surface. So we have ourselves a square backdrop. Okay, there we go. The label says it covers 27 meters squared. And he used the entire can, right? He used the entire can. So he covered this whole wall. So the area is 27. Estimate the backdrop's side length. So that is this length here. So we need to figure out what is this side length. Well, this side length would be the square root of 27, because we would figure that the side lengths are, because this is a perfect square, of course, and so side length times side length equals the area. So the square root of our area would be this answer. So square root of 27. So now we're going to take our number line, our friendly number line that we've been using, and we're going to find our two perfect squares on either side. So let's see. So we could do 5 times 5, which would give us 25. And then we could do 6, which would be 36. So it's going to be between 5 and 6. And 27 falls pretty close to 5, right? Okay. So this would be about maybe 5 points. What do we think? Maybe 2? 5.1? 5.1, I'll say, as my estimate. So they're just looking for an estimate. So we could say square root 27 equals, with a squiggly, 5.1. And now why don't we just check our answer in here? And we see it's 5.19. Okay, so pretty much 5.2. So my estimate was close, but the actual answer is 5.2, I would say, with rounding. So there we go. That is how we do it. So make sure you let me know if you have any questions, and we will talk to you soon.